Hello everyone, in this video we will discuss about premature optimization. Premature optimization is a mental model to detect and prevent optimizing the wrong thing at the wrong time or for the wrong reasons. This video builds a mental model to distinguish between mature and premature optimization. We then proceed to talk about 7 important aspects to reduce risks of any optimization effort. Next we will discuss 3 keys of optimization. Optimization is the intentional process of changing systems, software, hardware, people, etc. to improve one or more aspects. Typically, it involves changes and trade-offs. Good optimization improves the right things at the right time and with reasonable trade-offs. However, change introduces risk, delay, failure, cost, etc. Premature optimization is when at least one of the following is true: changing the wrong thing. Examples: the team takes 6 months to rewrite a Java microserver to Rust to improve response time. After the rollout, they learned that the biggest source of delay was cross-region network dependencies. A non-technical manager falls in love with Dora metrics. His team sets up dashboards to track all but she's particularly focused on lead time. She uses carrots and sticks to get the team review PRs faster. The team games the system by making lots of pointless PRs to skew the data, for example updating inline code comments, picking the wrong time. Examples: a nerdy startup founder burns the budget to create Google-level infrastructure for its one endpoint API. The startup fails before discovering product market fit. First make it work, then make it better. As the market size was shrinking, a company realized that they need to rearrange their human resources to reduce waste and keep the balance sheets clean. So they decide to do a reorg. The J-curve, as we'll discuss in this article. The productivity takes a hit before getting better. Being too impatient, leadership panicked at the sign of the J-curve and went with the second best option on their table: layoff. Choosing the wrong trade-offs. Examples: leadership decides to switch observability provider to save cost. After 3 months of migration, but every reorg the team learns that the new provider has poor data quality and the support is crap. You get what you pay for. Developers of a game engine decide to refactor the critical parts of the code in assembly. This resulted in a 20% performance boost over the C++ code, but now the company has to increase the price to X to cover for the extra cost of development to support multi-platform and fix quirky bugs. In this picture now you have the 3 keys of optimization. This simple mental model enables you to quickly assess whether an optimization is mature or not. Ask the 3 T's before thinking about optimization. 1. Thing. Are we optimizing the right thing? Do we have data that supports it? Have we done the due diligence to avoid data bias? Is it a fact, or assumption, or belief fab? 2. Time. Is this the right time to invest in optimization? Is it too soon, late? Do we have a clear picture about the problem and various alternative solutions? Or should we wait for the problem space to evolve and various alternative solutions to mature? What's the time span till the investment pays off? 3. Trade-offs. Engineering is the art of trade-offs. Are we aware of the metrics that will be hurt by the optimization? What is the list of things that will surprise us when the optimization is done? Do we have contingency plan in place to reduce those risks? Are the consequences objectively worth the effort? Thank you for watching this video. Please like and provide your valuable comments. For more videos like this, please subscribe to our channel.